Hey there everybody, and welcome back to another Blender tutorial where in this one we're not doing particle disintegration, which is what everybody seems to be doing, but we are doing the antonym, the opposite day version of it, which is materialization. And you've probably been seeing a couple render results I've been making. It works with any mesh, whether it's primitive or something you edit moded or sculpted. It looks complicated, but it's not. So if you look at this and tell yourself, yes, I can't do it, then guess what? You're right, because we set our own limits, and the math for this one's not too complicated. It's only a couple nodes. So without further ado, let's fucking get it. So here's how we do it. I'm going to be using Blender 3.1 Alpha. I'm sure you're using 3.0. Don't feel lesser than. Don't feel inadequate or anything about it, because anything I do in 3.1, you can also do in 3.0. That's the magic of not that many features being added per augmentation, but whatever. Here's how we're going to do it. Go into geonodes, since this is all going to be a geonodes modifier, long story short, and I'm going to replace this geometry with whatever it is I want to materialize. In this case, I'm lazy, so I'm going to be using a primitive. So let's use the Suzanne. But again, edit mode, sculpt, do whatever you want. For the Suzanne, Control 3 to add a subsurf of level 3, just so we get something a bit cleaner with more geometry. You will find that it looks better this way. And let's hop into geonodes. So again, take a mesh, make it high res, and add geonodes. First thing we need to do is, what is this effect really? It's basically a bunch of points kind of materializing this thing from left to right. Long story short, we need points, and then we're just going to make the rule or the algorithm or the thing that we're gonna hit them with if they don't follow our command, and that rule is gonna be pretty simple. So let's distribute some points. This is gonna be a distribute points on face, and I'm just gonna increase the density until it looks like this thing is entirely composed of points, like we're building the atoms that make this thing up. So I'm gonna go for 1,000, but we're actually gonna go a lot higher than that. On each of these points, we need a little mesh, a little particle thing that we are going to be moving. So on each of these points, we've distributed our points. Let's do instance on points. And you could do anything for this. I would recommend a cube, because it uses only 6 faces and it's going to be super tiny. Anyways, so review. What have we done so far, everybody? We took a mesh, we geonoded it, we put a bunch of points on it, and on each point, we tied a little mesh that's going to be dragged back and forth. Specifically, we did a cube that is way too big. Beautiful at any size, but this is a bit too big. So let's take the scale and bring it down to 100th. So now you can see this is really outlining our mesh. And I'm going to take the density and bring it even more up. So you can see that it's really kind of outlining what this looks like. Something like that. Don't be afraid to use too many points. Nothing wrong with that. Okay. So we've distributed a bunch of points that make up our mesh, and we can also combine this with the original, so we have the underlying mesh underneath, but for now, this is what we have. The next step is we need to make the rule that says take these points and move them somewhere else. In other words, disintegration or materialization. Whenever I'm moving stuff, always, I use set position. So we've distributed points, we're going to reposition them, as you can see. This is what that does, and then we're going to tie each of these to a cube. In fact, the rule we're going to use for set position seems complicated, right? How do you project and materialize points? All we need to do is have 2 states for this. First of all, we're going to have the default position, which you can see does nothing. It basically means outline a monkey in this case. And the other version we're going to have is something like a vector, so like a combine XYZ, or you could do something else technically, but I'm going to make a point maybe up above. So this is 0, 0, 2. So I want you to imagine all the points are up here. If we now take these 2 states and mix them together, you can see we're going from one to the other. And maybe 2 was too high, so I'm going to do 1.5. So you can see we're moving all these points from one to the other, and it's kind of like it's being pinched infinitely tight at the top, since they're all being sent to the same point. And now, really what the effect is, it's saying make this transition, but not for every point, just ones that are a certain amount on the x-axis. That's the idea here. So here is how we're going to do that. I'm going to use another position node, although you could technically use the same one. It's fields. It works like that. But I'm just going to do another one for clarity. And what I'm going to do is I'm going to say, as we sweep along the x-axis, as we, it's like we're in prison, right? And we got to count all our prisoners. So we have them line up, and we're like, click, click, click. And as we're going down the line, we're telling them, move to the next location. That was actually a pretty good metaphor. So what we're going to do is we're going to look at the X channel and we're going to say, hey, Blender, for anything that's like X value greater than some threshold, use this. So in other words, make it the selection. So I'm just going to map it up there. And you can see now we're saying take some part of this mesh and remap it there, which kind of makes it look like we're slicing it in half. The magic of this is we're not just going to say, some points go directly there, but we're actually going to have the transition going from one to the other. In other words, instead of having this be set to 0 or 1, we can make a little function for that. The function is just going to be, let's have this number be the threshold. So we're saying, anything above this gets like sent up to the next position. We're going to say, look at the distance that we are away from this. In other words, how many people are going to be in front of me in line, right? When you're in a reading circle and you have to read out loud and you're like, oh shit, I'm going to be reading the 4th paragraph. So you start practicing it in your head. That's what we're doing here. We're making a function for that. The fuck am I talking about? So let's make a distance function. Take this, subtract it from a number. Actually, take the X and subtract it from this number. So we're taking the X channel, the line, and we're saying subtract it from this number. In other words, take the difference. If we take this and then run it through an absolute value, those of you who know a bit of math will know that's literally the distance between two things. It doesn't matter which order you have them. X minus Y absolute value is the distance along the real number line between X and Y. Long story short, just copy what I'm doing and connect this to the factor. And you can see now we have a smooth transition between these controlled by a single value. Look at that, it's just like magic. And you can see this is generally how we're doing the effect. So it's kind of like we're printing this from a single point that can be manipulated. And we could print from a different point. So it's actually super general in the sense. At this point, let's save. I always like to call my project something useful, something that would be like, yes, this is it. So I like to call it I have a Patreon. And I do. And if you don't want to make this one file yourself, there's a link in the description where you can support the best Blender channel on YouTube. Either way, we've done the printing thing, and now we just want to make it not look like dog shit. And I've learned a couple tricks for that. The main one is we basically have this rule. We're saying as we go along the x-axis, print, or in other words, switch between these values. If we distort that a bit, add a bit of chaos, a bit of randomness, it's going to look a lot better. How do we add the chaos? Good question. Ask Sonic. He's got some emeralds for that. Take a noise texture. This is a nice continuous source of randomness, and mix it with this position, which is affecting the x-coordinate. Effectively, so we combine these, we mix the randomness. You can already see it's kind of breaking this up. Set this to linear light for reasons I'm not going to explain right now. And you can see this is adding the nice chaos to it. It's looking more like sand, or like a nice projector beam or something like that, than it was before. It was a little too perfect. So we broke this up with some noise. And in fact, this randomness we can control with the noise parameters, as you can see. I've found, it kind of depends what you're going for, I found that low roughness actually looks better. You might think higher roughness would look better because it makes it more like unpredictable, but this is what I found works. So at this point, we have a nice setup. We can control how many points. If we want to make it few points, still works, a lot of points, and we'll probably bump up the number. That will also work. And now the question is, we have this thing that prints any mesh. We can swap out the Suzanne for something else. How do we actually also show the geometry? Because we're basically making points that outline it, but we don't have the underlying mesh. Good question, although there's no way you would have asked that. Take these points and combine them with the original mesh. So now we have Suzanne and the points, yin and yang, black and white, good and evil, I don't know, penis and vagina. You get the idea. We're going to join these together, and now we have points that are going on the monkey, but we don't want the whole monkey to be there. We want also the mesh itself to be printed. So here's how I'm going to do that. So we joined it with the original geometry. What we're going to do, I'm still thinking of yin and yang things in the back of my mind, but we're going to delete geometry, and basically we're going to make a function that says only delete the geometry that hasn't been printed yet. Long story short, we only want to keep geometry that's very close to some of these particles that have already been dropped down. In other words, we need a proximity function. Yay, geometry proximity. This is going to measure the distance between our Suzanne mesh and these points. So I'm literally going to take these distributed points that we've repositioned. That's going to be our target. Set this to points. Again, make sure you set this to points, otherwise it will not work. take this distance function, connect it, and now all we need to do is add a threshold. So we're going to say geometry that's within this proximity of these points be printed. So let's do a greater than, and you want to lower this number. Not to 0, but to something close to it. And you can see now only the mesh that's like near the particles is here. As you can see, it's being nice and printed. So we have 2 layers for this, points and geometry. By the way, I do want to mention, you'll notice as this geometry is getting printed, it's kind of like showing faces, right? Because it's saying, delete this face, hide this face, you know, whatever. Not hide. It will either delete a face or not delete it. You can see it's looking very jagged. That's why I subsurfed of level 3. If you want this to be even higher resolution, subdivide the mesh. And you can see you go like 2 layers deep and it's going to start looking really smooth, but it's also going to be very computationally expensive. That's right, which is why later in this tutorial we're going to be talking about a render farm. But for now we're not going to use this because it's a bit much. But you can see we have this nice printing effect. Only thing that's left, you'll notice, is after our geometry is printed. Well, I guess there's a couple things, but after this geometry is printed, you're going to notice we still have our particles, and I'd rather not have those. I'd rather have them go away. So simple thing we can do is we can use this distance function to also control the size of the particles. In other words, when the size is 0, it will basically be gone. So connect that there, and we just need to do a tiny modification on this because we want kind of the opposite of this. So the distance is growing, but we want to say as the distance gets really far off, shrink the thing to 0. So we want to take an inverse. Long story short, add a bit more math, set this to multiply add. -1 and 1 is going to flip 0 to 1 and 1 to 0, if you think about it. Because we take 0 to 1, multiply by -1, and now it's -1 to 0, and then you add 1, you've shifted up that interval. So let's see if I can walk the walk or if I just talk the talk. Seems like I just talked the talk. I think the missing component here is clamping on one of these. Maybe? Oh, it's because I put it in the offset. Dummy. Connect that to the scale is what I meant to say. There we go. And I think clamping is also useful. Yes, it seems to matter. But now you can see not only is it printing the geometry and all this, but as we get further away, now we're on the right, the particles on the left are getting scaled to 0. Okay? Last thing I want to talk about before we make these kind of glow and all this is you're going to notice that these numbers are basically the slider that controls the transition. You'd think it goes 0 to 1, right? But we start from like negative something and then go to positive something. It's not very predictable, and it's actually going to change with every mesh because it has to do with the bounding box of it and everything, because we're going from the leftmost x value to the rightmost x value. I'd like a way to turn this into a 0 to 1 interval. Here's how we do it. We're going to attribute statistic. Why? Good question. We want to say what is the minimum, the leftmost, and the maximum x value. And we can actually extract that information from this min and max. So here is how I plan to bake the cookie. We are going to use a position field. We're going to say, what do we care about? We care about the x location. For what geometry? For the original monkey. Yes, because we're trying to find the x component bounding box. So again, monkey, x component, and now we care about this min and max, which we can remap using a map range. If this is going over your head, you must have a tiny head. It's fine. Take minimum, take maximum, map it. Oh, wait. Minimum, maximum, x component, and map it to 0 to 1. Just had a bit of... Well, there it goes again. Just had a bit of... Fuck! I just had a bit of a brain fart. I think I inverted the process. I want min and max down here. Why? Because we want to input a number between 0 and 1. Does that make sense? I think it makes sense. So the idea is we connect this here. Then we're taking from 0 to 1, and we're mapping it minimum to maximum. I think that makes sense. Connect this here. Let's see if it works. So when this is set to 0, it should be pretty left. I think the fact that there's still a bit left over might have to do with the noise we added. So if we actually get rid of this noise, maybe, I don't know, 0 to 1. Okay. So now if we take this, we're going a bit off the rails here, but now if we take this and lower our minimum, and again, I'm assuming this has to do with noise or something like that, we add something that really makes it the minimum. I don't know. Something like that. Subtract 1. And now we set this to the maximum. Basically, I'm just trying to find the bounds here. then that should do it. Okay, let's try it. So we animate this from 0 to 1. Beautiful. Feel free to skip that step. That was kind of nonsense, but it does help in the grand scheme of things when you want to swap meshes and stuff like that. Okay, we have the printing. Forget what I just said. Let's make this thing look nice and sweet and ready to eat. So I'm going to, first of all, bump up the number of particles. Again, it's going to work. It's just going to be higher res. And second of all, we want to give this 2 different materials. So let's set material for the cube. Again, this is the thing that becomes all the particles because it gets instanced. So I'm going to set material here. And let's also set material for this deleted geometry, which is the printed monkey. So we need to make sure we have 2 basic materials for this. And, the render settings you can do yourself. I'll hold your hand, but if I hold your hand too long, you're never going to develop. So one of these is going to be the monkey, and the other one is going to be, say it with me, the particles. Just like that. So particles goes in particles, and monkey goes in monkey. So let's just make sure if we swap the particles, yes, there we go. So I'm just going to give this a super basic thing here. So in cycles, I'm just going to give this an emission of some kind of printy color, which is usually some kind of bright blue, something like that. Might want to lower the emission. And then for the monkey material, I'm just going to leave it as is. If you want to add an extra layer of detail, by the way, I'm going to bring this down because I'm about to do something crazy. What we're going to do is we're going to take all of these instances and we're going to turn them into actual geometry, which is important for what I'm about to do. Realize it so it's actual geometry. And then the benefit of this is if we now look at random per island, you can see each of these cubes has a random number between 0 and 1. If you don't realize instances, that's not going to work because it doesn't know what pieces of geometry are separate. And you can use this to actually get a couple different colors of blue, or you can randomize the emission. It basically makes not everything look the same. So now when we print from left to right, we have these blue particles that are printing the thing. I mean, maybe play around with some numbers and feel free to subdivide the mesh a bit more like I showed you. But that is the essence of the effect. And now let's talk about Concierge Render, the sponsor for this video, a render farm that's going to let you render this thing at full resolution with all the geometry without breaking your computer. Okay, so as mentioned, this tutorial is sponsored by Concierge Render, which is a Blender render farm that lets you render off there, whatever land you like to. I mean, really, it's just the basement of some building, but it lets you render on somebody else's hardware, and you just pay a little to download it, and it goes a lot faster, and then you don't have to burn down your own computer. So here is how we send it to Concierge Render. So basically what I've done is I've taken our effect, I just positioned our camera and animated the number. Again, just this single parameter that does the thing. I animated it so that, it just does a materialization effect. I'm happy with the blend. Here's what we do. First of all, make sure we're happy with our settings. So 24 FPS, I don't care. That's fine. We want to render from frame 1 to 30, PNG, blah, blah, blah. If you want motion blur, which I might recommend for this one, because this is what makes it look kind of like lasers coming down. Although we did realize our instances, which I don't think works like motion blur. With motion blur, enable it. Long story short, pick render settings, then, very important, go to external data and automatically pack resources. In this case, we have one packed resource because I used HDRI lighting. If you have any image or sound or asset in your blend file, that's going to pack it in, and when you upload it, it's going to come with that information, so that's important. Otherwise, it's not going to look like it does on your computer. Lastly, I like to clean up with all of these. Not all of them do anything in this case, but this is just going to get rid of some of the baggage, some of the stuff weighing down this blend, the old ball and chain. Okay, so now our blend is ready. I renamed it to, I think I misspelled materialization, but that's what it's called now. And we are going to go to conciergerender.com, where you can make an account if you don't already have one. I do. But when you make an account, you get $5 in free render credits, which is actually enough for this project and a bunch of other projects. So you can see I have $10.50 here, should be plenty. So I'm going to go to upload and launch renders. Which render are we going to upload or launch? The materialization one. So just type in the name of it, which again I misspelled. It's going to import that in. The bigger your blend file, the longer it's going to... Also, the slower your internet connection. But in this case, it's a small blend. Doesn't matter. Go to materialization, which is a 3.0 blend file. Actions, launch render. It's going to think about it for a moment, and then we're just going to pick a bunch of settings and be like, yes, we are locking it in, and then it's going to render, and then we download it. Okay, so now that our blend is done processing, we just click the buttons and then, Okay, so first of all, render platform, we are using 3.0, so I made sure to save that out as a 3.0 instead of a 3.1 file. I don't know if it matters, but either way, Blender 3.0, render engine cycles, animation, a lot of these settings are going to be imported, by the way. So for example, in frames and resolution, indeed, we had 30 frames. We wanted 1080 by 1080 since that's the resolution I made it. At 120, that's kind of weak. 400 samples. So you can see any setting from the blend, it imported it in, so that's nice. Finally, go to hardware, and this is where you pick, do you want the beefy GPUs or do you want the super beefy GPUs to render it? Of course, the faster renders, the slightly more you pay, so I usually stick with this option. But if you're like, oh, the boss is going to fire me if I don't render this in the next 5 minutes and he's hovering over my shoulder, click the other one. But this is fine. So we're going to hit render. It's going to put it in the render. I was going to say render queue. It's called job manager. Go to job manager, go to view details, and you can see it's going to start rendering our 30 frames as PNGs, blah, blah, blah. And they are going to show up here, and then we are going to download them, not one by one, but by hitting this download outputs button. So I will cut to when it's done rendering these frames, which shouldn't take that long. Oh, no. Spoke too soon. It already started rendering these. So you can see it's going to go from left to right. Either way, I'm going to cut to when it's over. Okay, so it's been like, I don't know if it even has been a minute since I cut. I think it says average frame duration, 9 seconds. The whole render cost 11 cents. So when I say inexpensive, I mean, it was only a second of animation, but still, we're not talking big bucks. 11 cents to render this thing at pretty high res. So let's see all 30 frames. Let's click one of them halfway in between. We should see some particles and a monkey. Indeed, we do. So it worked. So you can either download individual frames or download outputs is going to zip them. So either way, concierge render, that's what it is. And check it out. I'll link in the description. And also what? I hope you learned something in this tutorial. If you didn't, you're lying. I know I taught you something. Thank you for watching, and I will see you in the next one. Love and peace.